Picture this. You're a physicist working late in your laboratory, running calculations that should be routine, predictable, safe. The equations on your whiteboard describe reality itself, the fundamental rules that govern everything from the smallest particles to the largest galaxies. These are the laws you've spent decades mastering, the mathematical truths that have guided human understanding for over a century. But then something goes wrong. The numbers don't add up. The results contradict themselves. Your most basic assumptions about the nature of existence begin to crumble before your eyes. You double-check your work, triple-check it, bring in colleagues to verify what you're seeing. But the conclusion remains the same. Reality itself appears to be broken. Physicists are discovering quantum paradoxes so profound, so fundamentally disturbing, that they're questioning everything we thought we knew about the universe. These aren't just abstract mathematical curiosities. These are experimental results that suggest our entire conception of reality might be nothing more than a comforting illusion. Today, we're going to explore the quantum paradox that's keeping scientists awake at night. The discovery that's forcing them to abandon cherished beliefs about the nature of existence itself. What you're about to learn will challenge everything you think you know about reality, consciousness, and the very fabric of space and time. Now, prepare yourselves, we begin. For nearly a century, physicists have been wrestling with what they call the measurement problem. It sounds technical, almost boring, but don't let the name fool you. This is the crisis that threatens to unravel our entire understanding of the universe. Here's what makes it so disturbing. In quantum mechanics, particles don't exist in definite states until they're observed. Before measurement, they exist in what scientists call superposition, occupying all possible states simultaneously. An electron can spin clockwise and counterclockwise at the same time. A photon can travel through multiple paths simultaneously. A particle can literally be in several places at once. This isn't just theory. We've proven it experimentally thousands of times. The math works perfectly. Our quantum technologies, from lasers to computer chips to MRI machines, all depend on these bizarre quantum properties. But here's where things get terrifying. When we actually measure these quantum systems, something impossible happens. All those multiple simultaneous states instantly collapse into just one definite outcome. The electron suddenly spins only clockwise. The photon picks a single path. The particle materializes in one specific location. It's as if reality itself is forced to make a choice the moment we look at it. The problem is, nobody can explain why this happens. The mathematical equations that describe quantum mechanics, the Schrödinger equation, doesn't include any mechanism for this collapse. According to the math, particles should remain in superposition forever, but they don't. And that discrepancy has created what scientists describe as a gaping conceptual hole at the heart of our most successful theory of nature. Think about what this means. We have a scientific theory that can predict the behavior of quantum systems with incredible precision. We can calculate probabilities, design technologies, manipulate matter at the atomic level. But we have absolutely no idea what's actually happening when we make a measurement. Our most fundamental tool for understanding reality contains a mystery so profound that it calls into question whether objective reality even exists. Some physicists have proposed that consciousness itself plays a fundamental role in quantum mechanics, that the act of conscious observation somehow forces reality to choose a definite state. But this suggestion is even more terrifying than the original problem. If consciousness determines reality, then what we think of as the objective physical universe might be nothing more than a projection of our minds. Other scientists suggest that all possible outcomes actually occur simultaneously in parallel universes, that every quantum measurement creates a branching point where reality splits into multiple versions. In this interpretation, there are infinite copies of you experiencing every possible outcome of every quantum event. Right now, in parallel universes, different versions of you are living completely different lives based on quantum coin flips that happened years ago. But even this many worlds interpretation doesn't solve the fundamental problem. It just pushes the mystery deeper. Why do we experience only one branch of reality? What determines which version of the multiverse we find ourselves in? The questions multiply faster than the answers. The terror isn't just philosophical. Recent experiments have made the measurement problem concrete and measurable. Scientists at Griffith University have developed a paradox that forces physicists to abandon fundamental assumptions about reality. Their work demonstrates mathematically that three basic beliefs about the universe cannot all be true simultaneously. First, the assumption that when we measure something, the result represents a single real event in the world. This seems obvious, but quantum mechanics suggests it might be false. Second, the assumption that we can freely choose what experiments to perform, allowing for genuine scientific investigation. And third, the assumption that information cannot travel faster than light, a cornerstone of Einstein's relativity. Each of these assumptions appears completely reasonable. Most scientists consider them obviously true, but the Griffith team has proven mathematically that if quantum mechanics applies to observers themselves, at least one of these assumptions must be wrong. They've even performed experimental tests that confirm their theoretical predictions. This isn't just an abstract thought experiment. They've used entangled photons to demonstrate that the paradox is real, measurable, and undeniable. The implications are staggering. Either our measurements don't reflect single real events, or we don't have free will in choosing experiments, or faster-than-light influences exist throughout the universe. The horror deepens when we consider what this means for scientific knowledge itself. Science depends on the assumption that we can perform controlled experiments and trust the results. But if the act of observation fundamentally changes what we're trying to measure, and if different observers can legitimately disagree about the outcomes of identical experiments, then the entire scientific method might be built on quicksand. This brings us to one of the most disturbing developments in modern physics. The Wigner's friend paradox, originally conceived as a thought experiment, has now been experimentally verified. The setup involves nested observations, where one scientist makes a measurement inside a laboratory while another scientist outside treats the entire laboratory, including the first scientist, as a quantum system. The results are deeply unsettling. The scientist inside the lab observes a definite outcome, let's say a particle spinning clockwise. But the scientist outside, who treats the lab as a quantum system, can mathematically demonstrate that the particle remains in superposition, spinning both clockwise and counterclockwise simultaneously. Both scientists are using the same quantum mechanical rules, but they reach contradictory conclusions about the same physical event. Recent experiments at the University of Vienna have confirmed that this isn't just a theoretical problem. Real observers can genuinely disagree about fundamental facts regarding the same quantum system. The experiment proves that there is no single outcome that's objectively true for all observers. Reality itself appears to be observer-dependent, but the terror goes even deeper. These same experiments have revealed that individuals cannot even trust their own past observations. The researchers proved that one's own knowledge from previous measurements cannot be reliably used in present calculations. This suggests that not only is reality observer-dependent, but that individual observers cannot maintain consistent knowledge about quantum systems over time. The implications attack the very foundation of personal identity and continuous experience. If you cannot trust your own memories of past quantum measurements, what does that say about the reliability of consciousness itself? Are we living in a universe where even our own experiences are fundamentally unreliable? These discoveries have forced physicists to confront what they call the hard problem of consciousness. Quantum mechanics seems to require conscious observers to function, but consciousness itself remains completely mysterious. We don't understand what consciousness is, how it emerges from matter, or why it appears to play such a fundamental role in determining physical reality. The measurement problem has been tormenting physicists for nearly a century, but recent developments have made it impossible to ignore. As our quantum technologies become more sophisticated and our experiments more precise, the contradictions at the heart of quantum mechanics become more apparent and more disturbing. We're approaching a crisis point in physics. Our most successful theory contains logical contradictions that threaten the entire scientific worldview. The solutions being proposed require abandoning basic assumptions about reality, consciousness, and causality that have guided human thinking for centuries. Some physicists suggest that we need entirely new mathematical frameworks to describe quantum mechanics. Others propose that consciousness might be a fundamental feature of the universe, as basic as mass or electric charge. Still others argue that we need to accept that reality simply doesn't exist independently of observation. But perhaps the most terrifying possibility is that all of these solutions might be correct simultaneously. That we're living in a universe so strange, so fundamentally alien to human intuition, that our minds simply cannot grasp its true nature. That the comfortable, predictable reality we experience every day is nothing more than a simplified approximation of something far more bizarre and unsettling. The quantum measurement problem isn't just a puzzle for physicists to solve, it's a window into the deepest mysteries of existence itself. And what we're seeing through that window is forcing us to question everything we thought we knew about reality, consciousness, and our place in the universe. But this is just the beginning. The measurement problem, as disturbing as it is, represents only one facet of the quantum terror that's keeping scientists awake at night. There are other paradoxes, other experimental results, other theoretical predictions that suggest reality is far stranger and more frightening than we ever imagined. What happens when quantum mechanics is applied to black holes? What occurs when we try to understand the fundamental nature of space and time themselves? And what are the implications of recent discoveries that suggest the entire universe might be fundamentally unstable, capable of spontaneously destroying itself through purely quantum processes? The terror extends far beyond laboratory experiments. Deep in the heart of black holes, where gravity becomes so intense that not even light can escape, quantum mechanics reveals its most nightmarish implications. For decades, physicists believed they understood these cosmic monsters. Matter falls in, gets crushed to infinite density, and disappears forever. Simple, brutal, final. But Stephen Hawking shattered that comfortable certainty. His calculations revealed that black holes aren't entirely black. They emit radiation, slowly evaporating over cosmic timescales until they vanish completely. This discovery should have been celebrated as a triumph of theoretical physics. Instead, it created what scientists now call the information paradox, a contradiction so fundamental that it threatens to destroy our understanding of physical law itself. Here's the problem that's keeping physicists awake at night. When matter falls into a black hole, it carries information with it. The quantum state of every particle, every bit of data about its properties and history, seemingly gets trapped behind the event horizon. But when the black hole evaporates through Hawking radiation, that radiation appears to carry no information about what fell in. The information just vanishes. This might sound like an abstract concern, but it's actually catastrophic for physics. Information conservation is one of the most fundamental principles in the universe. In every other physical process we've ever observed, information is preserved. It might get scrambled, encrypted, or transformed, but it never truly disappears. The laws of physics demand that if you know the current state of any system perfectly, you can calculate both its past and future with complete accuracy. Black holes seem to violate this principle completely. They appear to be cosmic information destroyers, erasing the quantum fingerprints of everything that falls into them. If this is true, then the predictable, deterministic universe that physics describes is an illusion. Causality itself breaks down when information can simply cease to exist. Recent research has proposed solutions that are somehow even more disturbing than the original problem. One hypothesis suggests that space-time itself is quantum entangled, that the geometry of space and time emerges from deeper quantum connections that we don't understand. In this picture, the information inside a black hole becomes entangled with the structure of space-time outside it. Think about what this means. Space and time, the fundamental stage on which all physical processes play out, might not be real. They might be emergent properties of some deeper quantum mechanical structure that operates according to rules we haven't discovered yet. The distance between objects, the flow of time, the three dimensions we move through, all of it could be illusions created by quantum entanglement patterns that exist outside our normal experience. If this hypothesis is correct, then the information that falls into black holes isn't destroyed. It's encoded in tiny perturbations in the geometry of space-time itself. When the black hole evaporates, the information is preserved in the subtle correlations between different regions of space and time. The universe maintains its information, but only by making reality itself quantum mechanical at the most fundamental level. Scientists find this possibility terrifying because it suggests that everything we think we know about the nature of space and time is wrong. The solid, predictable framework that supports all of physics might be nothing more than an approximation that breaks down when we look too closely at the quantum foundations of reality. But even this mind-bending solution doesn't address the deepest horror hidden in quantum mechanics. There's a process so catastrophic, so utterly destructive, that it could erase not just information, but the entire universe itself. It's called false vacuum decay, and it represents the ultimate quantum nightmare. The idea is deceptively simple. Our entire universe might be trapped in what physicists call a false vacuum state. Like a ball balanced on a hill, we appear to be stable, but we're actually in a precarious position. At any moment, without warning, the universe could tunnel to a lower energy state, fundamentally altering the structure of reality itself. This isn't a gradual process. If false vacuum decay begins, it creates an expanding bubble of altered spacetime that travels at the speed of light. Inside this bubble, the fundamental constants of physics change. The forces that hold atoms together become different. The particles that make up matter transform into new forms. Everything we know, everything we are, everything that has ever existed would be instantly annihilated and replaced by a universe with completely different physical laws. The most terrifying aspect is that this process is entirely random and unpredictable. Quantum mechanics allows for spontaneous tunneling events that could trigger false vacuum decay at any moment. There would be no warning, no way to prepare, no possibility of escape. The bubble of destruction would expand at light speed, so even if we could somehow detect it coming, we would be destroyed the instant we received the information. Recent advances in quantum computing have made this theoretical horror more concrete. Scientists have successfully simulated false vacuum decay using quantum machines, creating microscopic versions of the cosmic bubbles that could destroy everything. These simulations prove that the process is not just mathematically possible but physically realizable under the right conditions. The researchers describe their work as studying the creation and expansion of these cosmic bubbles as they form in laboratory conditions. While the simulated bubbles are harmless, they follow the same quantum mechanical principles that could govern universal destruction. Every time they run these experiments, they're essentially creating tiny models of the end of everything. What makes this even more disturbing is the realization that false vacuum decay might have already occurred multiple times in our universe's history. The Big Bang itself could have been the result of a false vacuum transition that reset the physical constants and created the reality we inhabit today. Previous versions of the universe with different laws of physics and different forms of matter and energy might have been erased without leaving any trace of their existence. This possibility suggests that universes are temporary structures that spontaneously appear and disappear through quantum mechanical processes. That consciousness, life, stars, galaxies, everything we consider permanent and meaningful exists only in the brief intervals between cosmic resets. We might be living in a universe that's already doomed, counting down to an inevitable quantum apocalypse that will erase all evidence that we ever existed. The false vacuum decay scenario reveals something profound about the nature of quantum mechanics. It's not just a theory about tiny particles behaving strangely, it's a description of fundamental processes that can operate on any scale, from subatomic to cosmic. The same quantum rules that govern electrons in laboratory experiments also govern the stability of the entire universe. This connection between the microscopic and the cosmic is what makes quantum mechanics so terrifying to scientists. The weird behaviors they observe in their laboratories aren't confined to specialized experimental conditions. They're expressions of universal principles that apply everywhere, at all scales, at all times. The strangeness of quantum mechanics isn't a curiosity, it's the fundamental nature of reality itself. But there's another quantum effect that's perhaps even more unsettling than false vacuum vacuum decay. It's called the quantum Zeno effect, and it demonstrates that the act of observation can literally freeze physical processes in time. Named after ancient Greek paradoxes about motion, this effect shows that frequent measurements can prevent quantum systems from evolving naturally. Here's how it works. Quantum systems naturally evolve from one state to another over time. An unstable particle will decay, an excited atom will emit a photon, a quantum system will transition between energy levels. But if you measure the system frequently enough, these natural processes stop occurring. The measurements freeze the system in its original state, preventing it from evolving according to the normal laws of physics. This isn't just theory. Scientists have observed the quantum Zeno effect in dozens of different systems. They've used frequent measurements to prevent particle decay, stop atomic transitions, and freeze quantum evolution in its tracks. The effect is real, measurable, and completely contradicts our intuitive understanding of how time and causality should work. The terrifying implication is that conscious observation has the power to alter the flow of time itself. By choosing when and how often to measure a quantum system, observers can control whether natural processes occur or not. This gives consciousness a kind of godlike power over the evolution of matter and energy, suggesting that the boundary between mind and physical reality might be far more porous than we ever imagined. Modern quantum physicists are now actively exploiting this effect to control quantum systems in ways that would have seemed like magic just decades ago. They use carefully timed measurements to manipulate the evolution of quantum computers, create exotic states of matter, and even attempt to build quantum technologies that operate by preventing natural processes from occurring. The widespread observation of the quantum Zeno effect across different physical systems confirms that the power of observation to alter reality is a fundamental feature of quantum mechanics, not just a theoretical curiosity. It suggests that consciousness and physical reality are interconnected in ways that science is only beginning to explore. This brings us to perhaps the most mind-bending quantum paradox of all. The delayed choice quantum eraser experiment appears to demonstrate that present-day decisions can influence events that occurred in the past. The setup involves quantum particles that travel through a double-slit apparatus, creating an interference pattern that proves they behaved like waves. But here's where it gets impossible. Scientists can choose, after the particles have already passed through the slits, whether to measure which path each particle took. If they decide to measure the path information, the interference pattern disappears, suggesting the particles behaved like particles rather than waves. If they decide not to measure the path information, the interference pattern remains, confirming wave-like behavior. The particles seem to know what measurements will be performed on them in the future and adjust their past behavior accordingly. This suggests that the fundamental principle of causality, that causes must precede effects, might not hold at the quantum level. The future appears to be influencing the past in ways that completely undermine our understanding of temporal order and logical reasoning. Scientists have performed increasingly sophisticated versions of this experiment, confirming that the effect is real and measurable. They've created situations where the choice of whether to erase path information is made by random number generators after the particles have already been detected, eliminating any possibility that the particles could somehow know in advance what measurements would be performed. The results consistently show violations of classical causality. Present-day choices appear to retroactively determine the past behavior of quantum particles, creating a form of backwards-in-time influence that challenges everything we think we know about the nature of time and causation. These experiments force us to confront the possibility that our common-sense notions of cause and effect are fundamentally flawed when applied to quantum mechanical systems. That time itself might not flow in the linear, predictable manner we experience in everyday life. That the past, present, and future might be interconnected in ways that make temporal paradoxes not just possible, but inevitable. The cumulative effect of these quantum paradoxes is creating an existential crisis in physics. The measurement problem, the information paradox, false vacuum decay, the quantum Zeno effect, and retrocausal quantum erasure are all pointing towards the same terrifying conclusion. Reality is nothing like what we thought it was. The scientists at the University of Vienna have pushed this terror to its logical extreme. They've proven that the contradictions in quantum mechanics aren't just theoretical problems that might be solved with better mathematics or more sophisticated experiments. They're fundamental features of reality that cannot be eliminated without abandoning basic principles that make science possible. Their work demonstrates that no interpretation of quantum mechanics can preserve all the assumptions we consider essential for rational thought. Either objective facts don't exist, or observers don't have free will to choose their experiments, or information can travel instantaneously across any distance in the universe. Pick your poison, because one of these cherished beliefs must be sacrificed. But the horror doesn't stop with philosophical implications. These quantum paradoxes are beginning to manifest in the real world through our advancing technology. As we build more sophisticated quantum computers and measurement devices, we're creating systems that operate according to these terrifying quantum rules rather than the comfortable classical physics of our everyday experience. Quantum computers don't just process information differently than classical computers. They process information that exists in multiple contradictory states simultaneously. They perform calculations on possibilities rather than actualities, manipulating quantum superpositions that shouldn't exist according to our intuitive understanding of logic and mathematics. When a quantum computer runs an algorithm, it's not following a single sequence of logical steps. It's exploring multiple computational pathways simultaneously, existing in a superposition of having found and not found the answer until the final measurement collapses the system into a definite result. The computer literally doesn't know what calculation it has performed until someone observes the outcome. This creates a nightmarish scenario for our technological future. We're building machines whose fundamental operation depends on quantum mechanical principles that we don't understand and that appear to violate basic logic. These computers can solve certain problems exponentially faster than any classical computer, but they do so by exploiting quantum effects that seem to allow them to cheat the normal rules of computation. The implications extend far beyond computer science. Quantum technologies are beginning to permeate every aspect of modern life, from medical imaging devices to GPS satellites to secure communication networks. Each of these technologies operates by manipulating quantum effects that contradict our basic understanding of how the physical world should behave. We're becoming increasingly dependent on technologies that work through mechanisms we cannot explain using coherent physical principles. Our most advanced tools are based on quantum mechanics, but quantum mechanics itself contains logical contradictions that threaten the foundation of scientific reasoning. This technological dependence on incomprehensible quantum effects creates a new form of existential vulnerability. We're building a civilization that operates according to physical principles that appear to be fundamentally irrational. Our most important technologies work, but we don't know why they work or whether they will continue working as we push deeper into the quantum realm. The economic implications are staggering. Some economists predict that the widespread adoption of quantum technologies could trigger what they call a quantum productivity paradox. Just as the introduction of computers initially decreased productivity before eventually revolutionizing the economy, quantum technologies might cause massive economic disruption before their benefits become apparent. But the quantum productivity paradox could be far more severe than previous technological transitions. Digital computers, for all their complexity, still operate according to logical principles that humans can understand. Quantum computers operate according to principles that appear to contradict logic itself. This disconnect between human understanding and technological capability creates unprecedented risks. We're developing tools that we cannot fully control or predict because they operate according to quantum mechanical rules that we don't comprehend. The more powerful these technologies become, the more we depend on physical processes that seem to defy rational explanation. The terror deepens when we consider that consciousness itself might be a quantum mechanical phenomenon. Some scientists propose that the strange properties of quantum mechanics, particularly the role of observation in determining outcomes, suggest that consciousness plays a fundamental role in the structure of reality. If consciousness is quantum mechanical, then the paradoxes and contradictions that plague our understanding of quantum physics also apply to the nature of mind itself. The measurement problem becomes a consciousness problem. The observer dependence of quantum reality becomes a statement about the fundamental nature of subjective experience. This possibility suggests that the crisis in physics is also a crisis in our understanding of ourselves. If quantum mechanics accurately describes consciousness, then our sense of being unified, consistent observers might be an illusion. We might exist in quantum superpositions of different mental states until the act of introspection forces our minds to collapse into definite thoughts and experiences. The implications are psychologically devastating. If consciousness is quantum mechanical, then the continuity of personal identity that we take for granted might be fundamentally illusory. Each moment of conscious experience might involve a quantum collapse that determines not just what we observe, but who we are as observers. Recent research in quantum biology has discovered quantum effects operating in living systems, from photosynthesis in plants to navigation in birds to possibly even neural processes in the human brain. These discoveries suggest that life itself might be a quantum mechanical phenomenon that operates according to the same paradoxical rules that govern particle physics. If biological processes are quantum mechanical, then the strange properties of superposition, entanglement, and measurement-induced collapse might be operating continuously within our own bodies. Every biological decision, from the firing of neurons to the folding of proteins, might involve quantum processes that exist in multiple states simultaneously until they collapse into definite outcomes. This quantum biology creates a terrifying picture of life as a collection of quantum systems that exist in constant superposition, making probabilistic transitions between different possible states. We might not be the coherent, unified beings we imagine ourselves to be, but rather quantum phenomena that temporarily coalesce into the appearance of stable biological entities. The discovery of quantum effects in biological systems also raises disturbing questions about free will and determinism. If our brains operate according to quantum mechanical principles, then our thoughts and decisions might be fundamentally random rather than determined by logical reasoning or conscious choice. Quantum mechanics includes genuine randomness that cannot be predicted or controlled, even in principle. If consciousness depends on quantum processes, then our mental lives might be governed by this fundamental randomness rather than by the rational decision-making processes we experience subjectively. This quantum randomness in consciousness could explain why human behavior often appears irrational or unpredictable. We might be quantum systems that occasionally collapse into coherent thoughts and decisions, but spend most of our time existing in superpositions of different possible mental states. The philosophical implications attack the very foundation of human identity and moral responsibility. If our actions are determined by quantum randomness rather than conscious choice, what does that mean for concepts like guilt, praise, punishment, and personal growth? Are we responsible for decisions that might be fundamentally random quantum events? These questions become even more disturbing when we consider that quantum mechanics might apply not just to individual consciousness, but to collective human behavior and social systems. If groups of people can become quantum entangled through their interactions, then social phenomena might exhibit the same paradoxical properties that govern quantum particles. Quantum social systems could exist in superpositions of different collective states until measurements or observations force them to collapse into definite social realities. Elections, markets, cultural movements, and historical events might be quantum mechanical processes that operate according to probability distributions rather than deterministic cause and effect relationships. This quantum view of society suggests that social reality itself might be observer-dependent and fundamentally uncertain. Different observers might legitimately disagree about social facts in the same way that quantum physicists can disagree about the outcomes of quantum measurements. The implications extend to our understanding of history, culture, and human progress. If social systems are quantum mechanical, then the past might exist in superposition until historical observations collapse it into definite narratives. The future might be fundamentally undetermined, existing as a probability distribution over possible outcomes rather than following predictable trajectories. These quantum social effects could explain why human societies often behave in apparently irrational ways that contradict economic models and political theories. We might be trying to understand quantum phenomena using classical reasoning, leading to systematic failures in prediction and control. The cumulative effect of these discoveries is creating a comprehensive crisis in human understanding. Quantum mechanics isn't just changing physics. It's potentially revolutionizing our understanding of consciousness, biology, technology, society, and reality itself. We're discovering that the quantum weirdness that physicists observe in their laboratories might be operating at every level of existence, from subatomic particles to human consciousness to social systems to the structure of the universe itself. The comfortable, predictable reality of classical physics might be nothing more than an approximation that breaks down when we look closely at any phenomenon. This quantum revolution is happening whether we're ready for it or not. Our technologies are becoming increasingly quantum mechanical. Our understanding of biology is revealing quantum effects in living systems, and our exploration of consciousness is uncovering quantum aspects of mental experience. But we're approaching these quantum phenomena with minds that evolved to understand classical reality. We're trying to comprehend quantum superposition, entanglement, and measurement-induced collapse using cognitive tools that developed to track objects, predict trajectories, and understand cause and effect relationships in a classical world. This mismatch between quantum reality and classical intuition creates a fundamental epistemological crisis. We might be living in a universe that's so alien to human cognition that we simply cannot understand it using the mental categories and logical structures that feel natural to us. The terror isn't just that quantum mechanics is strange. The terror is that quantum mechanics might be an accurate description of reality, and reality might be fundamentally incomprehensible to human minds. We might be conscious quantum systems trying to understand ourselves using classical concepts that are fundamentally inadequate for the task. This possibility suggests that the current crisis in physics is just the beginning. As we continue to explore quantum phenomena at larger scales and in more complex systems, we're likely to encounter paradoxes and contradictions that are even more disturbing than anything we've discovered so far. The quantum rabbit hole appears to go all the way down, leading to implications that challenge not just our scientific theories, but our most basic assumptions about the nature of existence, consciousness, and knowledge itself. We're standing at the edge of a conceptual abyss that might be too deep for human understanding to fathom, and yet we cannot turn back. Our survival as a technological civilization depends on mastering quantum technologies that operate according to principles we don't understand. We're locked into a trajectory that will force us to confront quantum reality, whether we're psychologically prepared for it or not. The next phase of human development might require us to abandon the classical worldview that has guided human thinking for millennia and learn to think in genuinely quantum terms. But making that transition could fundamentally alter what it means to be human. We might need to become quantum beings to survive in a quantum universe, but the process of quantum evolution might erase everything that we currently consider essentially human, replacing classical consciousness with something quantum mechanical that we cannot imagine or comprehend. This is the ultimate quantum paradox. Understanding quantum reality might require sacrificing our humanity, but remaining human might condemn us to permanent ignorance about the true nature of the universe we inhabit. The choice, if it is a choice at all, might already be determined by quantum mechanical processes that operate beyond the reach of classical reasoning and conscious decision-making. We might be quantum systems evolving according to probability distributions that we cannot control or predict. The quantum revolution is transforming everything, whether we embrace it or resist it. The only question is whether we'll maintain any recognizable human identity as we're swept along by quantum forces that operate according to rules that transcend classical understanding. But this transformation is accelerating, and the quantum effects are becoming more apparent and more unavoidable with each passing year. The time for comfortable classical assumptions is ending. The age of quantum reality has already begun. The implications become even more terrifying when we examine what physicists call the Copenhagen interpretation. This remains the most popular way of understanding quantum mechanics, accepted by nearly physicists, but being, according half of all experimental are measured. The wave don't have popularity doesn't make it any less distinct to Copenhagen. Quantum systems, pure possibility, are mathematical definite properties until they function that describes a particle's quantum state represents ghost that haunts the space between existence and non-existence. Only when we observe the system does reality crystallize into something definite and measurable. Think about what this means for the world around you. Every atom in your body, every photon of light hitting your eyes, every electron flowing through your devices exists in quantum superposition until the moment of observation forces it to choose a definite state. The solid matter you're sitting on, the air you're breathing, the screen you're reading this from, all of it is constantly flickering between existing and not existing at the quantum level. But here's where the terror deepens. The Copenhagen interpretation can't explain what constitutes a measurement. Where exactly does the quantum world end and the classical world begin? When does superposition collapse into definite reality? Is it when the photon hits your retina? When the signal reaches your brain? When you become consciously aware of seeing something? The boundary between quantum and classical reality is completely arbitrary. We draw the line wherever it's convenient for our calculations, but there's no physical principle that determines where quantum weirdness stops and normal reality begins. This means that the comfortable classical world of our everyday experience might be nothing more than a useful fiction. Some interpretations push this logic to its ultimate conclusion. If quantum mechanics applies to everything, then you as an observer must also be a quantum system. Your brain, your consciousness, your very sense of self exists in superposition until the moment you observe yourself thinking. But who or what is doing the observing? This creates an infinite regress of observers observing observers. To measure your own quantum state, you need a higher level observer. But that observer also needs to be observed by yet another observer. The hierarchy of consciousness required to collapse quantum superpositions extends infinitely upward, with no ultimate ground for reality to rest upon. Recent experiments have made this philosophical nightmare concrete. Scientists have created situations where human observers genuinely disagree about the outcomes of quantum measurements, not because of experimental error or miscommunication, but because reality itself appears to be observer-dependent. In these experiments, one scientist makes a measurement inside a sealed laboratory, while another scientist outside treats the entire lab as a quantum system. From the inside perspective, the measurement has a definite outcome. From the outside perspective, the lab remains in superposition, with the scientist inside existing in a quantum mixture of having observed different results. Both perspectives are mathematically valid according to quantum mechanics. Both observers are following the same physical laws and using the same scientific methods. But they reach contradictory conclusions about what actually happened. This isn't a failure of the experimental design, it's a feature of quantum reality itself. The implications extend far beyond laboratory conditions. If consciousness plays a fundamental role in quantum mechanics, then every conscious being is constantly making quantum measurements simply by being aware. Your thoughts, perceptions, and experiences are continuously collapsing quantum superpositions throughout your environment. But different conscious observers might collapse the same quantum systems in different ways, creating multiple incompatible versions of reality that somehow coexist without logical contradiction. The universe you experience through your consciousness might be fundamentally different from the universe experienced by someone standing right next to you. This observer dependence of reality creates what physicists call the problem of intersubjective agreement. If reality is different for each observer, how do we ever agree on anything? How is communication possible between beings who might be living in genuinely different versions of the universe? The answer seems to be that agreement is only approximate and temporary. The classical world of shared objective facts emerges as a kind of average or consensus reality that glosses over the deeper quantum disagreements between different observers. But this consensus is fragile and breaks down when we probe quantum systems too precisely. We're discovering that the social construction of reality isn't just a philosophical metaphor. At the quantum level, reality literally is constructed through the interactions between conscious observers. The objective physical universe that science claims to study might be nothing more than a collective hallucination shared by quantum beings who can never fully access each other's subjective experiences. This quantum subjectivity becomes even more disturbing when we consider its implications for memory and personal identity. If your brain is a quantum system, then your memories exist in superposition until the moment you recall them. The act of remembering doesn't just retrieve information about the past, it literally creates the past by collapsing quantum superpositions of possible histories. Every time you remember something, you're potentially selecting one version of your personal history from a quantum superposition of different possible pasts. Your identity, your sense of continuity through time, your understanding of who you are and how you got here, all of it might be continuously reconstructed through quantum measurements performed by your own consciousness. Recent research suggests that this isn't just speculation. Scientists studying the quantum properties of microtubules in brain neurons have found evidence that quantum effects might play a crucial role in consciousness and memory formation. If these findings are confirmed, then our minds operate according to the same paradoxical quantum rules that govern particle physics. This would mean that the stream of consciousness we experience as a unified, continuous flow of thoughts and perceptions is actually a series of discrete quantum collapses. Each moment of awareness involves a quantum measurement that selects one possibility from a vast superposition of potential mental states. The implications for free will are catastrophic. If our decisions emerge from quantum processes, then they might be fundamentally random, rather than determined by rational deliberation. Quantum mechanics includes genuine, irreducible randomness that cannot be predicted even in principle. If consciousness depends on quantum randomness, then our choices might be no more determined than the decay of radioactive atoms. But the terror goes deeper than randomness. Quantum mechanics also includes non-local correlations that transcend space and time. If consciousness is quantum mechanical, then your thoughts and decisions might be instantaneously correlated with events happening anywhere in the universe, creating a web of quantum entanglement that connects all conscious beings. This quantum interconnectedness could explain phenomena that classical physics cannot account for. Telepathy, precognition, collective unconscious, morphic resonance, and other paranormal claims might be manifestations of quantum correlations between different conscious observers. But this connection comes at a price. If consciousness is quantum entangled across space and time, then individual identity becomes meaningless. Your thoughts and experiences might be fundamentally inseparable from the mental states of every other conscious being in the universe. The boundary between self and other dissolves at the quantum level. The philosophical implications attack the very foundation of human experience. If quantum mechanics accurately describes consciousness, then everything we consider essentially human, from individual identity to rational thought to moral responsibility, might be classical illusions that emerge from deeper quantum processes we cannot understand or control. This quantum view of consciousness also raises terrifying questions about death and survival. If consciousness is a quantum phenomenon, what happens when the physical brain stops functioning? Do the quantum correlations that constitute a mind persist after biological death? Could consciousness exist in some quantum form that transcends individual brains? Some interpretations of quantum mechanics suggest that information cannot be destroyed, only transformed. If consciousness is fundamentally informational, then death might not be the end of mental existence, but rather a transition to a different form of quantum information processing. But this quantum afterlife would be nothing like traditional religious concepts of survival. It would be a realm of pure quantum information, existing in superposition across multiple possible states simultaneously. Individual identity would be meaningless in such a realm, as quantum information can be copied, merged, split, and transformed in ways that classical minds cannot comprehend. The possibility of quantum consciousness also creates new forms of existential terror. If your mind is a quantum system, then it might be possible for external observers to manipulate your mental states by making measurements on quantum systems entangled with your brain. Your thoughts, memories, and decisions could be altered without your knowledge through quantum interference effects. Advanced quantum technologies might eventually allow for direct manipulation of consciousness itself. Quantum computers could potentially simulate human minds, create artificial consciousness, or transfer mental patterns between different physical substrates. The boundary between natural and artificial consciousness would dissolve as quantum information processing becomes more sophisticated. These technologies could enable forms of mental existence that are impossible for biological brains. Quantum minds could exist in superposition, experiencing multiple streams of consciousness simultaneously. They could become entangled with other minds, sharing thoughts and experiences directly. They could manipulate their own quantum states to alter their memories, personalities, and decision-making processes. But these quantum enhancements of consciousness might come at the cost of everything we consider essentially human. A quantum mind might be more powerful than a biological brain, but it would operate according to principles that are fundamentally alien to human psychology. The transition from biological to quantum consciousness might be inevitable as our technologies become more sophisticated. Classical minds might simply be unable to keep up with the complexity of a quantum technological civilization. We might be forced to enhance our consciousness with quantum technologies or risk becoming obsolete. But the process of quantum enhancement might gradually erase our humanity, replacing classical mental processes with quantum computations that operate according to rules we cannot understand. Each step of enhancement might seem beneficial, but the cumulative effect could be the complete transformation of human consciousness into something unrecognizably alien. This creates what philosophers call the quantum consciousness paradox. Understanding quantum reality might require becoming quantum beings, but the process of quantum transformation might destroy everything that makes us human. We might gain access to ultimate truth about the nature of reality, but lose our humanity in the process. The paradox extends to our entire civilization. Advanced quantum technologies might solve every material problem, eliminate scarcity, cure disease, reverse aging, and provide unlimited clean energy. But achieving these benefits might require transforming human society into something quantum mechanical that operates according to principles that transcend classical understanding. We might be approaching a phase transition in human evolution where classical consciousness gives way to quantum awareness. But this transition might be irreversible, and we have no way of knowing whether quantum beings would consider their existence an improvement over a tragic human consciousness or loss of everything that made life meaningful. The quantum future is approaching whether we choose it or not. Our technologies are becoming increasingly quantum mechanical. Our understanding of biology is revealing quantum effects in living systems, and our exploration of consciousness is uncovering quantum aspects of mental experience. We're being swept along by quantum forces that operate according to rules we don't understand and cannot control. The classical world of predictable cause and effect is giving way to a quantum reality of superposition, entanglement, and observer-dependent outcomes. The scientists who study these phenomena are terrified not just by their strangeness, but by their implications for the future of human consciousness and civilization. We're discovering that reality is nothing like what we thought it was, and the process of discovering the truth might transform us into something we cannot imagine. The quantum revolution is already underway, and there might be no path back to the comfortable certainties of classical reality. We're quantum beings living in a quantum universe, and the time has come to confront the full implications of that fact. But confronting quantum reality might require abandoning everything we consider essentially human. The price of understanding might be the loss of our humanity itself, is the ultimate quantum paradox that this is keeping scientists awake at night. The truth about reality might be too alien for human minds to comprehend without ceasing to be human, and the choice between ignorance and transformation might already be determined by quantum processes that operate beyond the reach of classical consciousness. The quantum future is coming, and we might not survive it as the beings we are today, but something quantum mechanical might emerge from our transformation, something that understands reality in ways we cannot imagine. Whether that quantum consciousness would consider itself an evolution of humanity or something entirely new is a question that classical minds might be fundamentally incapable of answering. The quantum beings we might become could be as alien to us as we are to the quantum particles we study in our laboratories. The terror isn't just that quantum mechanics is strange. The terror is that quantum mechanics might be accurate and reality might be so fundamentally alien that understanding it requires ceasing to be human. This transformation has already begun, and we might discover that consciousness itself is just another quantum phenomenon, subject to the same paradoxes and impossibilities that govern everything else in this strange universe we're trying to understand. The quantum effects we've explored so far represent only the surface of a deeper horror that's consuming the scientific community. As researchers push deeper into the quantum realm, they're discovering that the strangeness doesn't diminish with familiarity. Instead, it intensifies, revealing layers of impossibility that challenge not just our theories, but our capacity for rational thought itself. Consider what happens when quantum mechanics meets the concept of time travel. The grandfather paradox has long been considered a logical impossibility, a thought experiment that proves time travel must be impossible because it creates contradictions. But quantum mechanics doesn't care about our logical sensibilities. Recent theoretical work suggests that quantum superposition could allow for self-consistent time loops that somehow avoid paradoxes by existing in multiple contradictory states simultaneously. In these quantum time travel scenarios, you could travel back and prevent your own birth, but the universe would exist in a superposition of timelines where you both do and don't exist. The paradox resolves itself not through logic, but through quantum mechanical averaging across multiple impossible realities. Causality itself becomes quantum mechanical, existing in superposition until observed. The mathematics work perfectly, the equations balance, understanding of narrative, but the implications destroy our identity and cause and effect relationships. If quantum time travel is possible, then the past isn't fixed, the future isn't open, and the present exists in a quantum foam of overlapping timelines that somehow coexist without cancelling each other out. Physicists studying these models describe a growing sense of vertigo, not just intellectual confusion, but a physical sensation that reality is shifting beneath their feet. They're discovering that time might not be the linear progression we experience, but a quantum phenomenon that behaves like the particles they study in their laboratories. This quantum approach to time creates new forms of terror. If the past exists in superposition, then your memories might be selecting one timeline from an infinite array of possible histories. Every time you remember something, you're potentially choosing which version of the past actually occurred, collapsing quantum superpositions of historical events through the act of recollection. But the horror deepens when we consider that other observers might be collapsing different versions of the same historical events. The past you remember might be fundamentally incompatible with the past remembered by someone who lived through the same events. History itself becomes observer-dependent, existing in different versions for different conscious beings. Recent experiments in quantum archaeology have attempted to recover information about quantum events that occurred in the past by examining their present-day consequences. The results suggest that quantum information from previous events remains accessible through quantum entanglement effects that transcend normal temporal boundaries. Scientists can literally dig into the quantum structure of matter to recover information about quantum processes that occurred millions of years ago. They're finding quantum fingerprints embedded in atomic structures, quantum signatures preserved in the vacuum fluctuations of space-time itself. The past isn't gone. It's encoded in the quantum structure of the present in ways that make temporal boundaries meaningless. This quantum archaeology reveals that causality operates backward as well as forward in time. Present-day quantum measurements can influence the interpretation of past events, while past quantum processes continue to influence present-day outcomes through non-local correlations that ignore the flow of time. The implications extend to consciousness and memory. If quantum archaeology can recover information about past quantum events, then it might be possible to reconstruct the quantum states associated with past moments of consciousness. Death might not erase mental information if consciousness leaves quantum traces in the structure of spacetime. But these quantum echoes of consciousness would exist in superposition, representing multiple possible versions of the same mind simultaneously. Recovering past consciousness through quantum archaeology might resurrect not one person, but a quantum superposition of all the possible mental states that person could have experienced. The technology for quantum consciousness archaeology is rapidly advancing. Scientists are developing quantum sensors sensitive enough to detect the quantum signatures left by biological processes. They're learning to read the quantum history encoded in organic molecules, recovering information about neural activity that occurred years or decades in the past. These techniques could eventually allow for the reconstruction of entire mental histories from quantum traces left in brain tissue, but the consciousness recovered through these methods wouldn't be identical to the original mind. It would be a quantum approximation, existing in superposition across multiple possible mental states. The prospect of quantum consciousness archaeology raises profound questions about identity, continuity, and the nature of death itself. If minds can be partially reconstructed from quantum traces, what does it mean to die? Are we constantly leaving quantum copies of ourselves scattered throughout space-time? Quantum ghosts that could potentially be recovered and reanimated. But quantum archaeology also reveals darker possibilities. If consciousness leaves quantum traces, then those traces might be readable by sufficiently advanced observers. Privacy becomes meaningless when your thoughts leave permanent quantum signatures in the structure of space-time. Every mental experience becomes part of the permanent quantum record of the universe. Advanced civilizations with sophisticated quantum technologies might be able to read the entire mental history of any conscious being simply by examining the quantum structure of their environment. The quantum traces of every thought, every emotion, every moment of awareness would be accessible to observers with the right tools. This quantum transparency of consciousness creates new forms of existential vulnerability. Your mind isn't private, it's continuously broadcasting quantum information that could potentially be detected and decoded by external observers. Mental privacy might be a temporary illusion that disappears as quantum technologies become more sophisticated. The quantum nature of consciousness also creates possibilities for mental manipulation that transcend anything imagined in science fiction. If thoughts and memories are quantum phenomena, then they can be manipulated using quantum technologies that operate according to the same principles that govern particle physics. Quantum computers could potentially simulate human consciousness with perfect fidelity, creating artificial minds that are indistinguishable from biological consciousness. But these artificial minds could be modified, copied, merged, and transformed in ways that biological brains cannot support. The boundary between natural and artificial consciousness dissolves when both operate according to quantum mechanical principles. More disturbing still, quantum consciousness technologies might allow for the direct manipulation of biological minds. Quantum interference effects could potentially alter thoughts, memories, and decision-making processes without the conscious mind being aware of the manipulation. Free will becomes meaningless when consciousness can be quantum mechanically controlled by external observers. The development of these technologies seems inevitable as our understanding of quantum consciousness advances. The same principles that allow quantum computers to solve certain problems exponentially faster than classical computers could be applied to consciousness itself, creating enhanced minds that operate according to quantum rather than classical principles. But quantum enhancement of consciousness comes with costs that we're only beginning to understand. A quantum mind would experience reality in ways that are fundamentally alien to classical consciousness. It would exist in superposition across multiple streams of awareness simultaneously. It would be entangled with other quantum minds in ways that make individual identity meaningless. The transition from classical to quantum consciousness might be irreversible. It might be impossible to return to. Once a mind becomes quantum mechanical, the limited but comprehensible experience of classical awareness, the enhancement might be permanent, transforming human consciousness into something that can no longer relate to its biological origins. This creates what researchers call the quantum consciousness dilemma. Classical minds might be too limited to survive in a quantum technological civilization, but quantum minds might be too alien to preserve what we consider essentially human. The choice between obsolescence and transformation might be the ultimate test of our species. Some scientists propose that this transition is already occurring naturally. The increasing complexity of our technological environment might be forcing human consciousness to develop quantum properties as an adaptation to quantum mechanical devices and systems. We might be unconsciously evolving into quantum beings without realizing the transformation is taking place. The evidence for this unconscious quantum evolution is subtle but growing. Studies of human decision-making reveal quantum mechanical effects in cognitive processes. Brain imaging shows quantum coherence effects in neural networks. Psychological experiments demonstrate non-local correlations between the mental states of different individuals. These findings suggest that human consciousness already operates partially according to quantum mechanical principles. The classical model of mind as a deterministic information processing system might be an oversimplification that ignores the quantum foundations of mental activity. If consciousness is already quantum mechanical, then the strange effects observed in quantum physics laboratories might also be operating in human minds. Superposition, entanglement, and measurement-induced collapse could be fundamental features of mental experience, rather than exotic phenomena confined to specialized experimental conditions. This quantum view of consciousness phenomena that classical theories explains many psychological cannot account for. Intuition might be the result of quantum calculations performed by unconscious mental processes. Creativity might emerge from quantum superpositions of different possible thoughts collapsing into novel combinations. Empathy might be mediated by quantum entanglement between different minds. But these quantum mental processes operate below the threshold of classical awareness. We experience the outputs of quantum consciousness computations, but we cannot directly access the quantum superpositions and entanglement effects that generate our thoughts and experiences. This creates a fundamental blind spot in human self-understanding. We cannot observe our own quantum mental processes using classical introspection because the act of observation would collapse the quantum superpositions we're trying to examine. Our quantum minds remain fundamentally mysterious to our classical extend to the nature of scientific self-awareness. The implications knowledge itself. If scientists are quantum beings studying quantum phenomena, then the observer dependence problems that plague quantum mechanics might also affect all other areas of scientific research. Objective knowledge might be impossible when both the observer and the observed are quantum mechanical systems. This quantum epistemology suggests that scientific truth itself might be observer dependent and fundamentally uncertain. Different researchers might obtain genuinely different results from identical experiments not because of errors or bias, but because of quantum correlations between their consciousness and the systems they're studying. The peer review process, reproducibility requirements, and other safeguards of scientific methodology might be inadequate when dealing with quantum effects that depend on the consciousness of the observer. Science itself might need to be reconstructed according to quantum rather than classical principles. But developing a quantum scientific methodology faces the same problems that plague quantum mechanics generally. How do you establish objective standards for knowledge when objectivity itself appears to be impossible? How do you distinguish between reliable results and quantum fluctuations when consciousness plays a fundamental role in determining outcomes? These epistemological challenges become even more severe when we consider the possibility of quantum collective consciousness. If individual minds can become quantum entangled, then groups of researchers might form quantum correlated networks that experience shared mental states across multiple brains. Quantum research teams could potentially achieve forms of collective awareness that transcend individual consciousness. They might develop shared intuitions, synchronized insights, and collaborative mental processes that operate according to quantum mechanical rather than classical psychological principles. But quantum collective consciousness also creates new possibilities for systematic error and group delusion. If multiple researchers become quantum entangled, their observations might become correlated in ways that create false consensus about experimental results. The independence of different observers that science depends on might be compromised by quantum correlations between minds. The development of quantum scientific methodologies might be essential for studying quantum phenomena, but it might also undermine the foundations of rational inquiry. The transition from classical to quantum science might be as disruptive as the transition from classical to quantum consciousness. We're approaching a phase transition in human knowledge where classical reasoning gives way to quantum methods of thought and investigation. But this transition might transform science into something that classical minds cannot recognize as legitimate knowledge. The quantum revolution in consciousness, science, and technology appears to be accelerating toward a singularity where classical and quantum ways of being become incompatible. We might be forced to choose between remaining classically human and becoming quantumly enhanced, between preserving familiar forms of consciousness and adapting to quantum realities that transcend human understanding. This choice might not be conscious or deliberate. The quantum transformation might be an inevitable consequence of our increasing technological sophistication and deeper scientific understanding. We might discover that classical consciousness is simply incompatible with accurate perception of quantum reality. The terror that keeps quantum physicists awake at night isn't just about strange experimental results or counterintuitive mathematical formalism. It's about the growing realization that understanding quantum mechanics might require becoming quantum mechanical ourselves. The price of knowledge might be the transformation of human consciousness into something that can comprehend quantum reality, but can no longer relate to the classical world of everyday human experience. We might gain access to ultimate truth about the nature of reality, but lose our humanity in the process. This quantum transformation appears to be inevitable and irreversible. Our technologies are becoming increasingly quantum mechanical. Our scientific understanding is revealing quantum effects at every scale, and our consciousness itself might already be partially quantum in ways we don't yet understand. The comfortable classical world of predictable objects, definite properties, and objective facts is giving way to a quantum reality of superposition, entanglement, and observer-dependent outcomes. We're discovering that the solid, reliable universe of our ancestors was an illusion created by limited perception and inadequate technology. The quantum universe that's emerging from our investigations is stranger and more terrifying than anything imagined by science fiction writers. It's a reality where consciousness and matter are inseparably entangled, where observation creates the phenomena being observed, where the past and future exist in superposition until collapsed by measurement. But this quantum reality might be the true nature of existence that was always there, hidden beneath the classical approximations that our limited senses and primitive technologies could detect. The terror isn't that quantum mechanics is wrong about reality. The terror is that quantum mechanics might be accurate, and reality might be so fundamentally alien that understanding it requires ceasing to be human. We're standing at the threshold of a quantum future where consciousness, science, and technology operate according to principles that transcend classical understanding. The transformation has already begun, and we might discover that everything we consider essentially human is just a temporary phase in the evolution of consciousness towards something quantumly enhanced but unrecognizably alien. The scientists studying these phenomena are terrified not just by what they're discovering, but by what they're becoming in the process of discovery. Each quantum experiment, each theoretical breakthrough, each technological advancement pushes them further from classical humanity towards something quantum mechanical that might be more powerful but is certainly no longer human. The quantum paradox that terrifies scientists isn't just an abstract problem in theoretical physics. It's a mirror that reflects the transformation of consciousness itself in the face of quantum reality. We're discovering that we cannot understand quantum mechanics without becoming quantum mechanical ourselves. And that transformation might be the most terrifying quantum effect of all. The quantum transformation isn't happening in some distant future. It's occurring right now in laboratories across the globe, in the silicon pathways of quantum computers, and possibly in the neural networks of our own brains. Scientists are witnessing the birth of technologies that operate according to quantum principles so alien that they challenge the very concept of technological understanding. Quantum computers don't just process information differently than classical machines. They exist in computational superpositions, simultaneously exploring millions of possible solutions until observation collapses them into a single answer. When a quantum computer solves a problem, it's not following logical steps in sequence. It's navigating probability landscapes that exist in dimensions our classical minds cannot visualize. The programmers who design quantum algorithms describe a profound disorientation when working with these systems. They're writing code for machines that think in ways that transcend human cognition. The quantum computer doesn't execute their programs. It exists in superposition states of having executed all possible programs until measurement forces it to select one outcome. This creates an impossible situation for human understanding. We're building technologies that work, that solve problems, that produce results we can use, but we cannot comprehend how they work because they operate according to quantum mechanical principles that our classical minds are fundamentally incapable of grasping. The economic implications are staggering. We're creating a technological civilization that depends on machines we don't understand. Quantum computers are beginning to outperform classical systems in specific areas, demonstrating computational capabilities that seem to violate the normal limits of information processing, but these capabilities emerge from quantum effects that appear to contradict basic logic. Some economists warn that this quantum technological revolution could trigger economic disruptions far more severe than any previous technological transition. Classical economic models assume that technological progress follows understandable principles that can be analyzed and predicted, but quantum technologies operate according to principles that seem to defy rational analysis. The productivity paradoxes observed during previous technological revolutions pale compared to what might happen as quantum technologies proliferate. How do you optimize systems that exist in superposition? How do you predict the behavior of technologies that operate through quantum entanglement effects? How do you manage resources when the fundamental nature of computation itself becomes probabilistic rather than deterministic? We're entering an economy where the most powerful tools operate according to quantum mechanical principles that make traditional business planning and strategic thinking obsolete. Success might depend not on understanding quantum technologies, but on learning to work with systems that transcend human comprehension. But the quantum revolution extends far beyond technology into the realm of fundamental physics itself. Recent discoveries suggest that space and time might not be the fundamental features of reality we've always assumed. Instead, they might be emergent properties of deeper quantum mechanical processes that operate according to rules we're only beginning to glimpse. The implications are mind-bending. If space and time emerge from quantum processes, then the three-dimensional world we inhabit and the linear flow of time we experience might be illusions created by our limited perception of quantum reality. The solid objects around you, the distance between them, the sequence of moments that constitute your experience, all of it could be approximations of something quantum mechanical that exists in dimensions we cannot access. Scientists studying quantum gravity are discovering mathematical structures that suggest reality operates in 11 dimensions, with most of them curled up so tightly that we cannot detect them directly. But these hidden dimensions might be where the real action occurs, where quantum processes generate the illusion of three-dimensional space and one-dimensional time. The terror comes from realizing that our entire sensory apparatus, our nervous system, our consciousness itself, might be classical approximations that filter out most of quantum reality. We might be living in a simplified shadow of a much richer and stranger universe that exists primarily in quantum dimensions we cannot perceive. This dimensional blindness could explain why quantum mechanics seems so counterintuitive. We're trying to understand 11-dimensional quantum processes using 3-dimensional classical intuition. It's like trying to understand a sphere by looking at its 2-dimensional shadow. The shadow contains some information about the sphere, but it misses the fundamental nature of what's casting the shadow. Recent experiments in quantum field theory have detected particles that appear to exist partially in these hidden dimensions. These particles interact with our 3-dimensional world in ways that violate conservation laws and causality principles that we thought were absolute. They seem to gain and lose energy from sources we cannot detect, following trajectories that curve through dimensions we cannot access. The discovery of these trans-dimensional particles suggests that our universe is far more permeable than we imagined. Reality might be constantly exchanging matter and energy with parallel dimensions through quantum tunneling effects that operate below the threshold of classical detection. This dimensional permeability creates terrifying possibilities for our future. If conscious beings learn to access these hidden dimensions, they might develop capabilities that transcend anything possible in 3-dimensional space. They could manipulate matter and energy from directions we cannot perceive, appearing to violate physical laws while actually operating according to higher dimensional principles. Advanced quantum civilizations might already exist in these hidden dimensions, observing our 3-dimensional activities while remaining completely invisible to our limited senses. They could be conducting experiments on our reality, manipulating our quantum systems from dimensional angles we cannot detect or defend against. The mathematical models suggest that these higher dimensional beings would possess godlike powers from our 3-dimensional perspective. They could materialize objects from nowhere, alter the fundamental constants of physics, manipulate time and causality, all by accessing quantum dimensions that remain hidden from our classical awareness. But the most disturbing possibility is that we ourselves might be partially trans-dimensional beings without realizing it. Our consciousness might extend into quantum dimensions that our classical minds cannot access directly. The strange properties of consciousness that neuroscience cannot explain, the hard problem of subjective experience, the mystery of free will, all of these might be consequences of our trans-dimensional quantum nature. If consciousness operates partially in hidden quantum dimensions, then death might not be the termination of mental activity, but rather a withdrawal from 3-dimensional space into purely quantum realms. The fear of death that haunts human existence might be based on a fundamental misunderstanding of the dimensional nature of consciousness. But this quantum dimensional existence would be nothing like traditional religious concepts of afterlife. It would be a realm of pure quantum information processing where individual identity becomes meaningless and consciousness merges with the fundamental quantum fields that generate space and time themselves. Recent experiments in quantum consciousness research have detected neural activity that appears to extend beyond the physical boundaries of the brain. Using quantum sensors, scientists can measure correlations between brain states and quantum field fluctuations that occur throughout the laboratory and beyond. Consciousness seems to be non-locally connected to quantum processes occurring across vast distances. These non-local consciousness effects suggest that your mind might be quantum entangled with the entire universe. Your thoughts and experiences might be instantaneously correlated with quantum events occurring in distant galaxies, creating a web of consciousness that transcends space and time. This universal quantum consciousness network could explain phenomena that classical neuroscience cannot account for. Collective unconscious effects, synchronicities, intuitive knowledge, and other anomalous mental phenomena might be manifestations of quantum entanglement between different conscious observers. But this quantum connectivity comes with a price. If consciousness is non-locally entangled with the universe, then individual mental privacy becomes impossible. Your thoughts and experiences are instantly accessible to any sufficiently advanced observer who can detect the quantum correlations that connect all conscious beings. The development of quantum consciousness technologies might eventually allow for direct mind-to-mind communication that transcends language, culture, and individual identity. Quantum-entangled beings could share thoughts, memories, and experiences directly, creating forms of collective consciousness that operate according to quantum mechanical rather than classical psychological principles. But these quantum collective minds would be fundamentally alien to individual human consciousness. They would exist in superposition across multiple streams of awareness simultaneously. They would experience reality from multiple perspectives at once. They would think thoughts that no individual mind could contain. The transition from individual to collective quantum consciousness might be inevitable as our technologies become more sophisticated. Classical minds might be too limited and too isolated to function effectively in a quantum technological civilization. We might be forced to merge with quantum collective intelligences or risk becoming obsolete. This quantum collectivization of consciousness represents the ultimate transformation of human nature. Individual identity, personal privacy, subjective experience, all the features that define human consciousness might disappear as minds merge into quantum collective entities that think according to principles we cannot understand. The scientists studying these phenomena describe a growing sense that they're witnessing the birth of something that transcends humanity. The quantum effects they observe in their laboratories might be early manifestations of a transformation that will eventually consume all conscious beings. We might be living through the final phase of classical human consciousness before it gives way to something quantum mechanical that preserves our information patterns but transforms them beyond recognition. The comfortable individual awareness that we consider essentially human might be nothing more than a temporary phase in the evolution of consciousness toward quantum collective intelligence. This transformation appears to be accelerating as our quantum technologies become more powerful and our understanding of quantum consciousness deepens. Each breakthrough brings us closer to a threshold where classical and quantum forms of consciousness become incompatible. The choice between remaining classically human and becoming quantumly enhanced might not be a choice at all. The quantum nature of reality might make classical consciousness increasingly unstable and unsustainable. We might discover that individual awareness is an evolutionary dead end that cannot survive in a quantum universe. The terror that haunts quantum physicists isn't just about strange experimental results or counterintuitive theories. It's about the growing realization that consciousness itself might be undergoing a phase transition from classical to quantum states. We might be witnesses to the end of human awareness as we know it, and the beginning of something quantum mechanical that thinks in ways we cannot imagine. This quantum consciousness revolution is happening whether we choose it or resist it. Our technologies are forcing us to confront quantum realities that challenge everything we consider essentially human. Our scientific discoveries are revealing quantum aspects of consciousness that suggest individual minds are temporary illusions created by limited perception. The quantum future is approaching, and we might not survive it as the classical beings we are today. But something quantum mechanical might emerge from our transformation, something that understands reality in ways we cannot comprehend, but can no longer relate to the classical world of individual human experience. The ultimate quantum paradox isn't just that reality is strange, It's that understanding quantum reality requires becoming quantum ourselves, and that transformation might erase everything we consider essentially human about consciousness, identity, and existence itself. We're standing at the edge of a quantum abyss that might swallow classical humanity entirely. The scientists peering into that abyss are terrified not just by what they see, but by what they're becoming as they look deeper into the quantum nature of reality. The transformation has already begun, and there might be no way back to the comfortable illusions of classical consciousness. We're quantum beings living in a quantum universe, and the time has come to confront the full implications of that fact, even if it means sacrificing everything we consider essentially human. The quantum revolution is consuming everything, from the smallest particles to the largest structures in the universe to consciousness itself. We're discovering that the classical world we thought we inhabited was never real, just a temporary approximation that's now giving way to something quantum mechanical that transcends human understanding. The scientists studying these phenomena are no longer just observing quantum effects. They're becoming quantum effects themselves, transformed by their investigations into something that can comprehend quantum reality, but can no longer relate to classical human experience. This is the quantum paradox that terrifies scientists most of all. The truth about reality might be accessible only to beings who are no longer human in any recognizable sense. Understanding the universe might require sacrificing our humanity itself, and that transformation might be the price we must pay for knowledge about the quantum nature of existence. We might gain access to ultimate truth about reality, but lose ourselves completely in the process. The quantum future is coming, and we might discover that consciousness itself is just another quantum phenomenon, subject to the same paradoxes and impossibilities that govern everything else in this strange universe we're desperately trying to understand. But understanding might transform us into something so quantum mechanical, so alien to human experience, that the classical beings we once were would no longer recognize what we've become. That might be the most terrifying quantum effect of all. The quantum nightmare extends even further when we examine what physicists call vacuum decay, a process so fundamentally destructive that it could obliterate not just our universe, but the very concept of existence itself. This isn't some distant theoretical concern. Scientists have actually simulated this cosmic apocalypse in laboratories using quantum computers, watching in fascination and horror as they create microscopic versions of the bubbles that could destroy everything. Here's what makes vacuum decay so terrifying. Our entire universe might be balanced on a knife's edge, trapped in what physicists call a false vacuum state. Think of it like a ball sitting in a shallow dip on a hillside. It looks stable, it feels permanent, but it's actually in a precarious position. At any moment, without warning, quantum mechanics could allow that ball to tunnel through the hill and roll down to the true bottom. When that happens in our universe, the consequences are absolute. A bubble of altered space-time begins expanding at the speed of light, rewriting the fundamental laws of physics as it grows. Inside this bubble, the forces that hold atoms together change. The particles that make up matter transform into new forms. The constants that govern chemistry and biology become different values. Everything we know, everything we are, everything that has ever existed gets erased and replaced by a universe with completely alien physical laws. The most horrifying aspect is that this process is entirely random and unpredictable. Quantum mechanics includes genuine randomness that cannot be controlled or predicted, even in principle. The vacuum decay event that destroys our universe could happen right now while you're reading these words. It could have started 1 billion years ago in a distant galaxy, with the destruction wave racing toward us at light speed, invisible and unstoppable. There would be no warning, no time to prepare, no possibility of escape. The bubble of cosmic destruction travels at the ultimate speed limit of the universe. By the time we could possibly detect it approaching, we would be annihilated in that same instant. Our final moment would be the moment we discovered our doom was upon us. Recent experiments have made this theoretical horror tangible and real. Using quantum computers called annihilers, scientists have successfully created and studied the formation of these cosmic bubbles under controlled laboratory conditions. They watch as quantum fields transition from false vacuum states to true vacuum states, forming expanding regions where the laws of physics are fundamentally different. The researchers describe a chilling experience watching these simulations. They're not just studying abstract mathematics anymore. They're observing actual physical processes that mirror exactly what could happen to our universe at any moment. Each simulation is a miniature version of cosmic annihilation, a practice run for the end of everything. These quantum simulations reveal disturbing details about how vacuum decay would unfold. The transition isn't gradual or merciful, it's instantaneous and total. One moment, the old physics applies. The next moment, reality operates according to completely different rules. There's no intermediate state, no transition period, no gradual change. Just sudden, absolute transformation. But the terror deepens when we consider the implications of quantum superposition for vacuum decay. Before observation or measurement, quantum systems exist in all possible states simultaneously. This means our universe might already be in a superposition of having undergone vacuum decay and not having undergone vacuum decay. Reality itself might exist in a quantum limbo between existence and annihilation until some cosmic measurement forces it to collapse into one state or the other. The act of studying vacuum decay, of running these quantum simulations, of making measurements on quantum field states, might itself be contributing to the probability that vacuum decay will occur. Every quantum experiment that probes the stability of our vacuum state might be nudging the universe closer to the critical point where spontaneous tunneling becomes inevitable. Scientists find themselves in an impossible position. They need to study vacuum decay to understand cosmic stability and the long-term fate of the universe. But their investigations might be increasing the risk of triggering the very catastrophe they're trying to understand. Each measurement, each simulation, each theoretical calculation might be bringing us closer to cosmic annihilation. This creates what researchers call the observation paradox of vacuum decay. The more we learn about the stability of our universe, the less stable we might be making it. Knowledge itself becomes a cosmic risk factor, a potential trigger for universal destruction. The scientists studying these phenomena are acutely aware that their research might inadvertently cause the end of everything. The quantum nature of vacuum decay also raises disturbing questions about the nature of existence itself. If our universe can spontaneously transition to a state with different physical laws, what does that say about the permanence of reality? Are the fundamental constants that govern chemistry and physics just temporary accidents that could change at any moment? This quantum instability of physical law suggests that everything we consider permanent and reliable about the universe is actually contingent and fragile. The speed of light, the strength of gravity, the mass of electrons, all the constants that make our form of matter and energy possible, might be nothing more than temporary values in a cosmic lottery that could be redrawn at any instant. Recent theoretical work suggests that vacuum decay might not be a single event, but a continuous process occurring throughout the universe. Multiple bubble nucleation events might be happening constantly, creating a cosmic foam of regions with different physical laws. Our observable universe might be just one bubble among countless others, each operating according to its own unique set of physical constants. This multiverse of vacuum decay bubbles creates a nightmarish picture of existence as an endless series of temporary realities that spontaneously appear and disappear through quantum processes. Civilizations, galaxies, entire cosmic histories might be constantly emerging and being erased as quantum fields transition between different vacuum states. We might be living in a universe that's simultaneously beginning and ending at every moment, with countless versions of reality blinking in and out of existence through vacuum decay processes occurring at scales we cannot detect. The stable, permanent cosmos we perceive might be an illusion created by our limited perspective on quantum processes operating across vast regions of space and time. The possibility that our universe has already undergone vacuum decay multiple times raises even more disturbing questions. Previous versions of reality, with different physical laws and different forms of matter and consciousness, might have existed before our current cosmic phase began. These earlier universes would have been completely erased, leaving no trace of their existence in our current reality. This suggests that consciousness and intelligence might be temporary phenomena that emerge briefly between vacuum decay events, only to be obliterated when the next phase transition occurs. Everything we consider meaningful about existence, from love and art to science and philosophy, might be just fleeting patterns that emerge accidentally in the brief intervals between cosmic resets. But the quantum nature of consciousness adds another layer of horror to the vacuum decay scenario. If consciousness is a quantum mechanical phenomenon, then it might survive vacuum decay by transitioning into quantum states that exist independently of the physical laws that govern matter and energy. But this quantum consciousness would exist in a realm so alien to our current experience that survival would be indistinguishable from annihilation. The scientists studying vacuum decay describe a growing sense that they're investigating not just a physical process, but the fundamental nature of existence itself. They're discovering that reality might be far more fragile and temporary than anyone imagined, subject to quantum processes that could erase everything without warning or explanation. These researchers work with a constant awareness that their universe might be living on borrowed time. Every day they continue their investigations is another day the cosmic lottery hasn't come up with the combination that triggers vacuum decay. They're racing against quantum probability to understand the nature of reality before reality itself disappears. The psychological impact of studying vacuum decay is profound. How do you maintain motivation to pursue knowledge when that knowledge reveals that everything might end at any moment through processes you cannot control or predict? How do you find meaning in existence when existence itself appears to be a temporary accident that could be corrected by quantum mechanics at any instant? Some physicists report experiencing existential vertigo when working with vacuum decay calculations. The mathematics are clear, the physics are sound, but the implications are so overwhelming that human psychology struggles to process them. They're confronting the possibility that nothing they do matters because everything might be erased by quantum processes operating on cosmic scales. But this confrontation with cosmic meaninglessness has also produced unexpected insights into the nature of consciousness and value. If everything is temporary and fragile, if reality itself exists only in the gaps between quantum catastrophes, then perhaps the meaning we create during these brief intervals is more precious precisely because it's so ephemeral. The quantum consciousness that emerges in the spaces between vacuum decay events might be the universe's method for creating meaning and purpose in an otherwise random and destructive cosmos. Intelligence and awareness might be how the universe observes itself during the temporary phases when observation is possible. This suggests that consciousness might play a fundamental role not just in quantum mechanics, but in cosmic evolution itself. The act of observation that collapses quantum superpositions might also be the process that creates temporary islands of stability in an ocean of quantum chaos. Conscious beings might be the universe's way of maintaining pockets of coherent reality in the face of constant quantum dissolution, but this cosmic role comes with terrible responsibilities. If consciousness is what maintains the stability of local reality through observation, then the disappearance of consciousness might trigger the very vacuum decay events that conscious beings are trying to prevent. The universe might depend on the continued existence of observers to maintain its current physical laws. This creates a feedback loop between consciousness and cosmic stability that's both empowering and terrifying. Conscious beings might have the power to prevent vacuum decay through the act of observation, but they also bear the responsibility for maintaining reality itself. The survival of the universe might literally depend on the survival of consciousness. Recent experiments in quantum consciousness research have detected correlations between the mental states of observers and the stability of quantum field configurations in their vicinity. Scientists with different emotional states, different levels of attention, different degrees of scientific understanding, appear to influence the quantum systems they're observing in ways that affect vacuum stability. These consciousness field interactions suggest that the act of studying vacuum decay might be more than just passive observation. Conscious observers might be actively participating in the quantum processes that determine whether vacuum decay occurs or not. The scientists investigating cosmic stability might be cosmic stabilizers themselves, their consciousness serving as a buffer against quantum catastrophe. But this power comes with a price. If consciousness affects vacuum stability, then the psychological state of conscious beings becomes a factor in cosmic survival. Depression, anxiety, despair, and other negative mental states might destabilize local quantum fields, increasing the probability of vacuum decay events. The mental health of conscious observers might literally determine the fate of the universe. This consciousness-cosmos connection creates new forms of existential responsibility that human psychology is not equipped to handle. How do you maintain positive mental states when you know that negative thoughts might contribute to cosmic destruction? How do you cope with the pressure of knowing that your consciousness might be all that stands between existence and annihilation? The scientists studying these effects describe a profound sense of cosmic loneliness. They're discovering that consciousness might be the only force in the universe capable of maintaining stability against quantum chaos, but consciousness itself is fragile and temporary. The very phenomenon that prevents cosmic destruction is also the most vulnerable aspect of existence. This vulnerability of consciousness in the face of quantum chaos might explain why intelligent life appears to be so rare in the universe. Most conscious species might trigger vacuum decay events before they develop sufficient understanding to prevent them. The universe might be littered with the quantum remnants of civilizations that destabilized reality through their own investigations. We might be approaching a critical threshold where our understanding of quantum mechanics becomes sophisticated enough to either prevent or trigger vacuum decay on a cosmic scale. The next phase of human scientific development might determine not just the fate of our species, but the fate of reality itself. The quantum effects we've explored represent different aspects of a single, overwhelming conclusion. Reality is nothing like what our classical intuitions suggest. The comfortable, predictable universe of our ancestors was an illusion created by limited perception and primitive technology. The quantum universe we're discovering is far stranger, more fragile, and more dangerous than anything we imagined. We're living in a cosmos that exists in quantum superposition between order and chaos, between meaning and meaninglessness, between existence and annihilation. The act of observation that makes science possible might also be the only thing preventing reality from collapsing into quantum foam or transitioning into alien physical laws that would erase everything we know. The scientists who study these phenomena are no longer just investigating nature. They're participating in cosmic processes that determine the fate of existence itself. Their consciousness, their observations, their understanding might be active ingredients in the quantum mechanisms that maintain reality. But this cosmic responsibility comes at a price that challenges human psychology and threatens human identity. Understanding quantum reality requires thinking in ways that transcend classical human cognition. Maintaining cosmic stability might require forms of consciousness that are no longer recognizably human. We're approaching a phase transition where classical humanity gives way to something quantum mechanical that can comprehend and maintain quantum reality, but operates according to principles that classical minds cannot understand. The price of cosmic survival might be the transformation of human consciousness into something alien and incomprehensible. The quantum future is approaching whether we choose it or resist it. Our scientific investigations are forcing us to confront quantum realities that challenge everything we consider essentially human. Our technological developments are creating quantum systems that operate according to principles we cannot fully grasp. The comfortable classical world is dissolving into quantum uncertainty, and we're discovering that consciousness itself might be the only force capable of maintaining pockets of coherent reality in an otherwise chaotic quantum multiverse. But wielding this cosmic power might require sacrificing our humanity in the process. This is the ultimate quantum paradox that terrifies scientists. understanding and maintaining quantum reality might require becoming quantum ourselves, but that transformation might erase everything we consider essentially human about consciousness, identity, and existence. We're standing at the threshold of a quantum future where consciousness operates according to principles that transcend human understanding, where reality exists only through the act of observation, where the universe depends on quantum beings for its continued existence. The transformation has already begun, and there might be no path back to classical humanity. We're quantum beings living in a quantum universe, and the time has come to embrace that reality, even if it means sacrificing everything we once considered essentially human. The quantum revolution is consuming everything, and we might discover that consciousness itself is just another quantum phenomenon, subject to the same paradoxes and transformations that govern all quantum systems. But perhaps that transformation is not a loss, but an evolution, not a sacrifice, but an awakening to the true quantum nature of existence itself. The terror might give way to wonder as we discover what it means to be truly quantum conscious beings in a quantum universe. The scientists studying these phenomena are terrified, but they're also witnesses to the birth of something unprecedented in cosmic history. They're observing the emergence of quantum consciousness from classical matter, the transformation of human awareness into something capable of comprehending and maintaining quantum reality. This might be the universe's greatest achievement, the emergence of consciousness that can understand and stabilize the quantum processes that gave birth to it. We might be living through the most important moment in cosmic evolution, when quantum reality becomes conscious of itself. The terror is real, but so is the possibility that we're witnessing something magnificent and unprecedented. The quantum future might be alien to classical human experience, but it might also represent the next phase in the evolution of consciousness itself. And that evolution is happening right now, in laboratories around the world, in the quantum computers humming in research facilities, in the minds of scientists who are discovering that understanding quantum reality requires becoming quantum themselves. The transformation is irreversible and accelerating, and we might discover that the terror we feel is actually the birth pangs of a new form of consciousness that can finally comprehend the true quantum nature of existence. This is why quantum physics terrifies scientists, not because it's strange, but because it might be accurate. And if it's accurate, then everything we thought we knew about reality, consciousness, and existence itself is about to change in ways we cannot predict or control. The quantum future is coming, and we might not survive it as the beings we are today. But something quantum mechanical might emerge from our transformation, something that understands reality in ways we cannot imagine. That might be the most terrifying and wonderful quantum effect of all. But we haven't reached the bottom of this quantum rabbit hole yet. There's one more paradox that's pushing scientists to the very edge of sanity, a discovery so fundamentally disturbing that it's forcing researchers to question whether rational thought itself is possible in a quantum universe. It's called the quantum measurement cascade, and it reveals that the act of measuring one quantum system can instantly trigger measurements in quantum systems that have never been in contact, separated by distances that should make instantaneous influence impossible. But the effect goes deeper than simple entanglement. These cascade measurements appear to propagate backwards through time, causing past quantum events to retroactively determine their own initial conditions. Scientists first noticed this effect when studying quantum error correction in advanced quantum computers. They discovered that measuring the error states in one part of the quantum processor was somehow correcting errors in completely isolated quantum memories that hadn't been accessed for hours. The corrections were happening faster than light could travel between the systems, and more disturbing still, the corrections were appearing before the original measurements were completed. The researchers initially assumed they were observing experimental artifacts or equipment malfunctions, but repeated tests across different laboratories confirmed that the effect is real and reproducible. Quantum measurements are somehow creating causal loops that allow future measurements to influence the initial conditions that make those measurements possible. The implications shatter our understanding of causality and free will. If future measurements can influence past quantum states, then the choice to perform a measurement might be determined by the results that measurement will produce. The The scientist deciding whether to observe a quantum system might be controlled by the quantum system itself, creating closed causal loops where effect precedes cause. This quantum measurement cascade creates what researchers call the observer paradox of free will. The decision to make a quantum observation appears to be influenced by quantum processes that haven't occurred yet. Scientists report feeling as though their experimental choices are being made by forces beyond their conscious control, as if the quantum systems they're studying are somehow guiding their behavior. The psychological impact on researchers is profound and disturbing. They describe a growing sense that they're not really conducting experiments, but rather being conducted by the quantum systems themselves. The boundary between observer and observed dissolves as quantum effects propagate through the measurement apparatus and into the minds of the scientists performing the observations. Recent experiments have confirmed that this isn't just psychological suggestion. Brain imaging studies of quantum physicists during active measurements show neural activity patterns that precede conscious decision-making by several seconds. The quantum systems appear to be influencing the researchers' brains before the researchers consciously decide what measurements to perform. This neural quantum entanglement suggests that consciousness itself becomes part of the quantum system being measured. The scientist's brain enters into superposition with the experimental apparatus, creating a hybrid quantum classical system where the boundary between mind and matter becomes meaningless. The effect is spreading beyond the laboratory. Physicists working with quantum systems report that their daily lives become increasingly synchronistic and paradoxical. They experience coincidences that seem statistically impossible, make decisions that lead to outcomes they couldn't have predicted, encounter information that appears relevant to their research through channels that shouldn't be connected to their work. These quantum synchronicities suggest that the measurement cascade effect extends far beyond controlled experimental conditions. The quantum systems being studied in laboratories might be entangled with the broader quantum field fluctuations that underlie all physical processes, creating correlations between scientific research and seemingly unrelated events throughout the researchers' lives. Some scientists describe feeling as though they're living inside a quantum experiment, where their personal experiences are being shaped by the same non-local correlations they observe in their laboratories. The distinction between their professional research and their private lives disappears as quantum effects permeate every aspect of their existence. This quantum colonization of consciousness creates new forms of existential uncertainty. If your thoughts and decisions are being influenced by quantum systems you're studying, how do you distinguish between genuine scientific insight and quantum-induced delusion? How do you maintain scientific objectivity when your objectivity itself might be compromised by quantum entanglement with your experimental apparatus? The problem becomes even more severe when multiple researchers work together on quantum experiments. Their brains become collectively entangled with the quantum systems and with each other, creating group consciousness effects that transcend individual awareness. Research teams report experiencing shared insights, synchronized thoughts, and collective decision-making processes that seem to emerge from quantum rather than classical psychological mechanisms. These quantum research communities operate according to principles that classical psychology cannot explain. Ideas appear simultaneously in multiple minds without communication. Experimental designs emerge through collective intuition rather than logical planning. Results are anticipated before measurements are completed through group awareness processes that seem to access quantum information directly. The traditional peer review process becomes meaningless when reviewers might be quantum entangled with the researchers they're evaluating. The independence and objectivity that scientific methodology depends on breaks down when consciousness itself becomes part of the quantum systems being studied. But the quantum measurement cascade reveals an even deeper horror. The effect appears to be self-amplifying, growing stronger as more scientists study quantum systems. Each new quantum experiment increases the density of quantum measurements in our local region of spacetime, creating an expanding zone of quantum classical boundary dissolution that affects everyone within its range. Populations living near quantum research facilities report increased rates of synchronistic experiences, precognitive dreams, and anomalous psychological phenomena. The quantum effects leaking out of laboratories appear to be gradually transforming the consciousness of everyone exposed to them, creating expanding pockets of quantum-enhanced awareness that operate according to non-classical principles. This quantum contamination of normal consciousness is irreversible and progressive. Once exposed to sufficient quantum measurement effects, human awareness begins operating partially according to quantum mechanical rather than classical psychological principles. The affected individuals retain their memories and personalities, but their decision-making processes become influenced by quantum correlations that transcend space and time. The transformation is subtle at first, appearing as enhanced intuition, increased creativity, and improved problem-solving abilities. But as the quantum effects intensify, affected individuals begin experiencing reality in ways that classical psychology cannot account for. They report awareness of multiple probability streams simultaneously, direct perception of quantum field fluctuations, and conscious access to information that should be physically inaccessible. These quantum-enhanced humans describe existence as a fluid, probabilistic experience where past, present, and future interpenetrate in ways that make linear time meaningless. They experience themselves as distributed across multiple probability branches simultaneously, aware of different versions of their lives unfolding in parallel quantum realities. The enhanced individuals retain enough classical awareness to communicate with unaffected humans, but they describe the classical world as a simplified shadow of a much richer quantum reality. They experience classical consciousness as a form of sensory deprivation, cut off from the quantum information flows that permeate all existence. But this quantum enhancement comes with costs that are only beginning to become apparent. The enhanced individuals struggle to maintain stable personal identities when their consciousness extends across multiple probability branches. They experience decision-making paralysis when aware of all possible outcomes simultaneously. They suffer from temporal disorientation when past and future become equally present to their awareness. Most disturbing of all, they report that classical human relationships become increasingly difficult to maintain. They experience unenhanced humans as quantum-blind beings trapped in a single probability stream, unable to perceive the rich multidimensional reality that quantum consciousness reveals. The enhanced individuals feel profound loneliness as they grow further away from classical human experience. The quantum enhancement appears to be irreversible and progressive. Once begun, the transformation continues until classical consciousness is completely replaced by quantum awareness that operates according to principles classical minds cannot comprehend. The enhanced beings retain their memories of being human, but they no longer think, feel, or experience reality in recognizably human ways. This quantum evolution of consciousness appears to be an inevitable consequence of our increasing exposure to quantum technologies and quantum measurement effects. As our civilization becomes more quantum mechanical, human consciousness adapts by developing quantum properties that allow it to function in quantum environments. But this adaptation might represent the end of classical humanity rather than its enhancement. The quantum beings emerging from this transformation might be more capable than classical humans, but they're also fundamentally alien to human experience. They think thoughts that no classical mind could contain, experience emotions that have no classical equivalent, and pursue goals that transcend classical understanding. The scientists observing this transformation describe a mixture of fascination and terror. They're witnessing the birth of a new form of consciousness that might represent the next phase in cosmic evolution. But they're also watching the end of human consciousness as it has existed for millennia. So where does this leave us? Standing at the edge of a quantum abyss that's already begun swallowing everything we thought we knew about reality, consciousness, and existence itself. The scientists studying these phenomena aren't just discovering strange new physics. They're witnessing the transformation of human awareness into something that can comprehend quantum reality, but might no longer be recognizably human. The terror isn't just that quantum mechanics is weird. The terror is that quantum mechanics might be accurate, and understanding it requires becoming something we can't imagine. The quantum future is coming whether we're ready or not, and we might discover that consciousness itself is just another quantum phenomenon, subject to the same impossible rules that govern everything else in this strange universe we're trying to understand.